Dear students, in the last class I have explained one of the applications of PN junction diode, which is rectifier. So what is a rectification? Process of converting an alternating current into direct current is called as rectification, and the circuit used for this purpose is called as rectifier, in which the main device that is used is a PN junction diode. And which properties of the diode is used in rectifier? It's a unidirectional property, ability of the diode to conduct only in one direction. Now, based on the application, some more semiconductor PN junction diodes are designed. That's based on the properties, and these are only for a specific application, and these devices are called optoelectronic devices. Now, what are optoelectronic devices? Any semiconductor diodes in which carriers are generated by photons are called as optoelectronic devices. Carriers means we are talking about the charge carriers. One is a negatively charged electron and the other is a positively charged holes. And when these are created by the photons, such devices are called as optoelectronic devices. There are three types of optoelectronic devices. The first one is a photodiode. The second one is a light emitting diode, and the third one is a solar cell. So these are the three optoelectronic devices which are used for certain applications. So let's see one by one the different device. So I'm going to start with a photodiode. So if I consider a PN junction diode, so this is the depletion region, this is the P side and this is the N side. And if I connect this in the reverse bias, which means the P side is connected to the negative terminal of the battery and N side is connected to the positive terminal of the battery. When we do this, the diode is in the reverse bias, and in reverse bias a very small current flows of the order of microampere. So this is that negligible current that flows through the circuit, and which we can measure by connecting a microammeter in the circuit. Now, if I allow light or suitable radiation to fall near the junction, then this radiation consists of photon carrying energy is equal to h nu. And if this energy is greater than the energy gap between the valence band and the conduction band, then electrons and holes are created here, and the electrons will move towards the N region and the holes will move towards the P region, and that will result in a current. So therefore, the current through the circuit increases because this photon creates the charge carriers here. Greater the intensity of the radiation, more is the number of photons, and greater the number of photons, more is the charge carriers, and greater the charge carriers, more is the that is current, that's current that results due to the radiation. That means intensity and the current are directly related. So that means this current produced in the device is directly proportional to the intensity of the radiation. And this device, which we call photodiode, it works in a reverse bias only. And the symbol used for this photodiode is the symbol of the diode with the radiation falling on it. So this is the P side and this is the N side of it. So therefore, a photodiode is one in which whenever the radiation is incident, it increases the strength of the current. Greater the intensity, more is the value of the current. And if I1 is the current corresponding to one more intensity, and if I2 is the current again correspond to one more intensity, then definitely we can say that the intensity of this is more than that of this. So, this is in the absence of the radiation and this is in the presence of the radiation, and that is what this photodiode is all about. A photodiode is a p-n junction diode in which the reverse saturation current, so this is called reverse saturation current. It constant, that is why it is saturates, and then it is in the reverse bias, that is what is called reverse saturation current. So, reverse saturation current increases when it is illuminated with some light. So, it can be even invisible radiation also, need not be the visible light only. So, we can use the infrared, we can even use the ultraviolet radiation for this particular purpose to detect the intensity. So, therefore, what is a photodiode? Photodiode is a p-n junction diode in which the reverse saturation current increases when it is illuminated with some light. So, greater the intensity, more is the current, and that is the basis on which we can measure the intensity of the incident light, visible or invisible. So, this is how this device looks like. It is just looks like a diode, and somewhere here you can even see that small gap which is again of the space between the two regions, which is P and the N region. So, this is the device which looks like LED, but it is basically a photodiode. Now, where do we use this photodiode? So, photodiode is used to detect both visible and invisible radiations. So, as I have mentioned here, that is by measuring the current we can measure the intensity. So, that is why it is used to detect the presence of the visible and the invisible radiation. In fast switching circuits, so since it measures the variation in the intensity of the light, it is used in fast switching circuits. To measure the intensity of the light in cameras. So, in all digital cameras, so we have a provision where there is auto flash, automatic flash option is there. So, in which auto flash it will detect the light and then that flashes get activated, and then you can even see that option which is automatic variation the intensity of the screen. So, there is a photodiode that detects the intensity of the light, and accordingly the variation in the intensity of the screen changes. So, therefore, it is a highly used device in cameras. And then in OFC, which is optical fiber communication, as a detector of light. So, in optical fiber communication we use optical fiber, and at one end we use a source of the infrared, and to detect that at the other end of the optical fiber we need a device, and the device that is used is a photodiode. So, these are the four important applications of the photodiode. It is used to detect both visible and invisible radiations in fast switching circuits, to measure the intensity of the light in camera, and then in optical fiber communication it is used as a detector. Now, in one of the, so this is part of the mobile screen. So, where we have a camera here. So, this is the location of the camera, and this is the region where you get to see the two photodiodes, which is to detect the intensity, and this is for the flash. So, photodiodes are used, and in the camera we can locate where exactly it is present to see the variation in the intensity of the light. So, that is in mobile camera. Then this is the light meter, which is used by umpires in the cricket ground to check the intensity of the light, whether the light is enough to play the cricket or not. So, that is that umpire holding the light meter, which is used to measure the intensity of the light. So, this is the application part of the photodiode. Now, let us see one more optoelectronic device, which is a light emitting diode, LED. Now, whenever a photodiode is used, it is always used in reverse bias. But if we use a p-n junction diode in the forward bias, electron hole combination takes place near the junction. So, this is the depletion region, P region, N region. P region is connected to the positive terminal of the battery, N region is connected to the negative terminal of the battery. Now, whenever the diode is connected in the forward bias, the electron and hole combination takes place, and whenever they combine, they liberate energy, and that is emitted near the junction, and this kind of device is called as a light emitting diode. In photodiode, photon, which is nothing but quantum of energy, gives out electron and hole. That's in photodiode. Okay, that is a photon creates a charge carrier, and now when charge carriers are combined, we'll get back the energy, which is nothing but photon. So therefore, in LED, the phenomenon or the process is exactly opposite to that of the photodiode. So here, electron hole combination takes place, and that liberates the energy. That's why it is called light emitting diode. It emits not only visible light, but it emits even the invisible radiation also, like infrared. We have infrared diodes are available. So it's a commonly used device. You must have seen this kind of LED lights or the bulbs almost used in every device. There are LED televisions are there, LED bulbs are available now. So therefore, the conventional filament lamp is now replaced by LED because of many advantage of this device. So therefore, photodiode works in reverse bias, whereas LED works in forward bias. In photodiode, a photon incident near the junction creates electron hole charge carriers, whereas in LED it works in forward bias, where electron hole combination takes place near the junction, which gives out the light. So what is a LED? A PN junction which emits light when forward biased is known as a light emitting diode. A PN junction which emits a light when forward biased is known as light emitting diode. So what are the different applications of the diode, which is LED? So first application, it is used in 7-segment display in clocks, calculator, digital multimeters, etc. So this is called 7-segment display. So you must have seen in the digital voltmeters, ammeters which we have used in our lab. So that's nothing but 7-segment. Now this kind of display is there even in your calculator. Now why it is called a 7-segment? Because it has a 7 parts like this. So if you count, the number is 8 here, but there are 7 parts are there. 1, 2, 3, 4, 5, 6 and 7. By controlling the light in various parts, we can display the numbers. So by controlling the light for the rest of the parts, we get a number 9 here. So if I retain this, and then if I control the light here, this portion here, let's consider this part here, then we get the number 0. So like this, by controlling the light of the various parts, we get this kind of display. So this is called as a 7-segment display, because there are 7 parts are there in a particular display, which is highly used in all the digital devices, the digital clock, the digital watches, the digital meters, right, and even in digital calculator as well. So that's highly used application. The second one, it is used as an indicator for power on, overload, short circuit. You take any device, you take switch on a television. So there is an power indicator, either it's most of the time it is red or it can be even other color as well. Okay. So sometimes it will be yellow color or green color. You switch on the AC, switch on the refrigerator or the washing machine, everywhere there is a display, power on indicator is there. So that indicator is nothing but it's an LED, light emitting diode. So it is used as an indicator for power on, overload, short circuit. Even in inverter we find that display. Okay. So this is what you get to see. So all the indicators which are there, they are all nothing but LED. So moment you switch on, there is an indicator in most of the devices. Clear? So that's the highly used applications of the light emitting diode. Then infrared LEDs are used in burglar alarm system and TV remote control. In remote control TV, so the part which you are facing, the part of the remote which you are facing the television or AC or even music system, correct. So there is a small bulb like structure, either it is hidden or you get to see that bulb like structure. Okay. So which is something like this. So here it is. So this is that bulb like structure in a remote is nothing but it's an infrared LED. So you cannot see the light coming out of it actually. So but you can definitely hold it in front of the mobile camera. You can see the red light coming out of it. So infrared LEDs are used in most of the remote control, and since it is invisible, it is also used in burglar alarm system. Okay. And again it just looks like any ordinary LED. You can't make out whether it's whether it emits visible light or even the infrared. So this is the third applications of the LED. And the last one, it is used in optical fiber communication, OFC, as a source of light. See, to detect the light we use photodiode, but as a source of light we use LEDs in optical fiber communication. So these are important applications of the light emitting diode. So what are the advantages of the LEDs over the conventional incandescent lamp? So it is again a question that is from the examination. So the first advantage is that LED requires a low operational voltage and less power. That means it basically consumes a lesser voltage, it consumes a lesser power. So obviously we have to prefer always the devices which consumes less power and compared to the incandescent which consumes more power. LED has a longer life, so therefore obviously we always prefer devices which last longer, and that's why this is one of the advantage of the LED. And fast on off switching capacity, that means it gets switched on switched off very quickly, not just like filament lamp. So even if you take example of the tube light, you need a choke, and then that choke helps the tube light to glow. So it takes certain few seconds to glow. So here fast switching on off capacity is there. So it gets switched on very quickly, switched off very quickly. So that's why you don't need additional power, or it gets switched on and off very faster. So that's the advantage. And then fast action and no warm up time is required. So as I've mentioned, like in tube light, it requires certain warm up time. So that's why it will not glow immediately. It takes certain time to glow. I'm talking about the tube light where we use a choke and not the LED tube lights. Okay. So LED tube lights will glow again in no time, but the tube lights, where we use a choke box, at the center of that frame. So fast action, no warm up time is required. So therefore these are the four advantages of the LED over the conventional lamps. So LED requires a low operational voltage, low voltage and less power. LED has a longer life, it has a fast on off switching capacity, and the fast action and no warm up time is required. So these are the four advantages of the LEDs. The next device is a solar cell. Now you must have seen in the case of LED and then photodiode, we have used a source, a battery we have used, because we have to maintain the photodiode in the reverse bias, we have to maintain the LED in the forward bias. But solar cell is one in which we don't use any battery, because this cell itself generates the EMF. So that's why solar cell has the advantage over the other two devices. So EMF is generated by itself. So that is the advantage of the solar cell. So this is the P region, this is the N region, and this is the depletion region here, and this is connected to an external resistor. You don't find any battery here, because the cell itself generates the EMF. And now when radiation is incident, photons are incident near the depletion region, it produces the charges, that is charge carriers are produced. Which are the two charge carriers? Holes and the electrons, they are produced. And these holes and the electrons, so again the electron moves towards the P region here, holes moves towards the N region, and the separation of the charges takes place. And once they are separated, they are collected, collection of the charges takes place, and that creates an EMF between these two ends, or between the P region and N region. And if connected to an external resistor, the flow of the current takes place, and that is how in solar cell the light energy is converted into electrical energy. And the graph of current versus voltage is drawn in the fourth quadrant here, because current normally is given out, current is always given by the cell, but in this case this particular device itself acts like a cell. So that's why the current is drawn from the external device. Normally the current is given to the external device by the battery, but in this case the current is drawn from the external device. For that reason the current versus voltage is drawn in the fourth quadrant, and since it is a non-ohmic device, the graph is a non-linear graph. And here, so we have maximum current, the voltage is 0, so therefore it's called as a short circuit current, and here the voltage is a maximum, the current is 0, so which is called open circuit voltage. So open circuit voltage means 0 current, maximum voltage. Open circuit voltage means 0 current and maximum voltage, whereas short circuit current means a maximum current and the minimum voltage is called as a short circuit current. So that is the kind of the graph that we get in the case of solar cell. And in solar cell there are this process involves actually 3 stages or 3 processes by which it works. So first of all, what is a solar cell? The generation of the EMF by solar cell when light falls on it due to the following 3 basic processes. So the generation of the EMF by solar cell when light falls on it is due to the following 3 stages are involved. Which are those 3 stages? First one is the generation, where a photon falling near the junction, it generates charge carriers, which is electrons and the holes. And these charge carriers are separation. So electrons moves from the depletion region to the P side, and the holes they move to the N side. And these are collected. That is the third step, which is the collection. So therefore, this is how the solar cell works by 3 stages: generation, separation, and the collection. Now, where do we use this solar cell? The solar cell are used in solar heaters. They are used in calculators. You must have seen solar calculators there, correct? So you will find a small box like structure which is hidden near the corner, and we have and solar panels are highly used, especially in the satellites, because power required, so we have to generate continuously, and solar panels are very mandatory in the satellites. So students, I have explained 3 important optoelectronic devices, and these are important from the exam point of view. Easy 1 mark, 2 marks question will appear out of this, like mention the applications of the LED, mention the advantages of the LED, mention the applications of the photodiode. Such questions are possible from this particular topic. So, I am going to continue my remaining topic of this chapter in the next class.